Imagine this. Out there, in the infinite black expanse where sunlight fades to nothing and the solar wind gasps its last, a fragile relic of human ingenuity drifts like a ghost in the machine. It's Voyager 1, launched 48 years ago in 1977, a time when floppy disks were cutting edge and the internet was a dream whispered in labs. This tiny probe, with less computing power than your smartphone's calculator and batteries dimmer than a nightlight, was never supposed to outlast the disco era. Yet here it is, over 15.7 billion miles from home as of November 2025, hurtling through interstellar space at 38,000 miles per hour, whispering secrets back to us across a void that swallows light itself. But in the past year, something extraordinary happened. Amid routine engineering tweaks to keep its aging thrusters alive, Voyager 1's instruments picked up anomalies that have left scientists staring at their screens in awe. Subtle fluctuations in plasma waves, unexpected spikes in cosmic ray patterns, data so intriguing that it's forcing us to rethink the very edge of our cosmic neighborhood. What if this plucky survivor isn't just surviving? What if it's revealing that the boundary between our solar bubble and the galaxy beyond is far stranger, far more alive with mystery than we ever imagined? Stick with me as we unravel this tale, because by the end, you'll see why Voyager's story isn't just history, it's a cliffhanger for humanity's future in the stars. Let's rewind to the beginning, because to appreciate the miracle of Voyager's endurance, you have to grasp the audacity of its birth. In the summer of 1977, NASA seized a rare cosmic opportunity, a once every 176 years alignment of the outer planets that allowed a single spacecraft to slingshot from one gas giant to the next, like a pinball in the hands of gravity. Voyager 1 blasted off on September 5th from Kennedy Space Center, 16 days after its twin, Voyager 2, riding a Titan IIIe Centaur rocket into the heavens. These weren't marvels of modern tech. They were marvels of minimalist engineering. With just 68 kilobytes of memory, less than a grainy photo on your phone today, and 3 radioisotope thermoelectric generators, RTGs, producing a mere 470 watts of power, enough to run a couple of LED bulbs. The probes were designed for a 5-year joyride. Their mission? Snap the first close-ups of Jupiter and Saturn, then fade into the cosmic background. No one dared dream they'd still be phoning home nearly 5 decades later. And oh, what a ride it was. As Voyager 1 hurtled toward Jupiter in 1979, it unveiled a world of wonders that shattered our textbooks. Peering through its cameras, it captured the Great Red Spot not as a mere storm, but as a raging hurricane twice Earth's diameter, swirling with winds up to 400 miles per hour. It spotted active volcanoes erupting on Io, Jupiter's innermost moon, fiery plumes spewing sulfur 200 miles high, proving that our solar system harbors worlds as geologically alive as Earth. Voyager discovered 2 new moons, Thebe and Metis, and revealed a faint, dusty ring encircling the gas giant, invisible from afar. These images, beamed back in grainy black and white, weren't just pretty pictures. They were proof that the outer planets were dynamic laboratories of chaos and creation. Then came Saturn in 1980. Voyager 1 dove through the rings, revealing intricate braids and spokes woven from icy particles, shepherded by tiny moons like Prometheus and Pandora. It found 5 additional satellites, including the geyser-spewing Enceladus, now a prime target for searches for extraterrestrial life due to its subsurface ocean. These revelations didn't just expand our maps, they ignited imaginations, turning abstract orbs into vivid realms of storm and shadow. As the cameras powered down to conserve energy in 1990, Voyager pressed on, leaving the planetary playground behind, bound for the uncharted frontier beyond Pluto. Fast forward through the decades, and Voyager's journey morphed into something poetic, the Voyager interstellar mission. Crossing the termination shock in 2004, where the solar wind slows from supersonic to subsonic, the probe entered the Helios Heath, a turbulent buffer zone at the solar system's edge. Then on August 25, 2012, At 122 astronomical units, AU, from the Sun, it pierced the heliopause, that invisible membrane where the Sun's influence wanes and the galaxy's raw plasma takes over. Voyager 1 became the first human artifact in interstellar space, a pioneer in the void. But crossing wasn't the clean break scientists expected. Instead of a sharp magnetic flip, the field's only nudged by 2 degrees, and plasma density surged without the predicted drop-off. Voyager 2, trailing on a different path, echoed the anomaly in 2018, detecting identical quirks 6 years later. These twins in discord suggested the heliopause isn't a static wall, but a rippling, dynamic skin, perhaps warped by solar activity or interstellar pressures, forming magnetic flux tubes that act like cosmic highways, funneling particles in and out. Recent data from 2024 and 2025, analyzed with modern AI tools, has amplified these puzzles. Subtle wave echoes, like whispers in a vast hall, hint at magnetic bubbles, pockets of compressed fields that Voyager has been threading since 2012. As of mid-2025, with Voyager 1 now 169 astronomical units out, about 25.3 billion kilometers. These readings are revolutionizing our models of the heliosphere, showing it's not a perfect bubble, but a frothy, breathing barrier against the galaxy's onslaught. Yet as Voyager delves deeper, the real drama unfolds in the engineering war room at NASA's Jet Propulsion Laboratory, JPL, in Pasadena. Picture this: a team of graying wizards, hunched over 1970s schematics updated with 2025 code, battling entropy across 23-hour one-way light delays. The RTGs, fueled by plutonium-238's slow decay, lose 4 watts annually. By November 2025, they're down to about 220 watts, barely enough for the essentials. Instruments have been methodically shut down, cameras in 1990, ultraviolet detectors in 1991, and more recently, the cosmic ray subsystem in February 2025, and Voyager 2's low-energy charge particle instrument in March. Thrusters clogged with hydrazine residue after decades of disuse became a crisis in early 2025. The primary roll thrusters failed back in 2004, forcing reliance on backups that were themselves faltering. With the Deep Space Network's Canberra antenna, Voyager's sole lifeline for commands, scheduled for upgrades from May 2025 to February 2026, engineers had a ticking clock. In a nail-biting May maneuver, they revived long-dormant backups, firing them successfully just days before the blackout. It worked. A test on March 20th confirmed the fix, buying precious months. But glitches persist. In late 2024, a faulty chip in the flight data subsystem garbled transmissions for weeks, only resolved by mid-November 2025 when the X-band transmitter was reactivated. These aren't just fixes. They're acts of defiance, extending a mission that should have ended in the 1980s. Each success feels like a heartbeat in the dark, reminding us that Voyager's true genius lies not in its tech, but in the human stubbornness that keeps it alive. Now let's lean into the fascination, the insights that make Voyager's data not just numbers, but portals to wonder. In interstellar space, where cosmic rays should bombard unchecked, Voyager has mapped a surprising calm. Fewer high-energy particles than predicted, filtered by the heliopause's wall of scorching plasma at 30,000 to 50,000 Kelvin. This hot wall, confirmed in 2025 analyses, acts like a cosmic sieve, shaping how galactic winds sculpt our stellar neighborhood. Magnetic field data reveals no full reversal, but a persistent knot tying solar and interstellar influences, suggesting the heliosphere is a leaky fortress, not an airtight dome. Plasma waves, those faint ripples Voyager's instruments still catch, pulse with rhythms tied to solar events light years away, echoes of the sun's tantrums rippling through the galaxy. And the onboard golden record, that time capsule of Earth's sounds from whale songs to Chuck Berry riffs, encoded with hydrogen's 1,420 megahertz frequency as a universal hello, now floats as Voyager's silent ambassador. Though unreadable from afar, its math, pi, primes, atomic spectra, mirrors the very signals Voyager detects, blurring the line between our message and the cosmos's reply. These aren't dry facts. They're invitations to awe. They challenge us. Is the universe an indifferent expanse or a conversation waiting to happen? As Voyager charts local interstellar clouds toward Ophiuchus, it's sketching a map not just of space, but of our place in it, proving that even in silence we're connected. But here's where the story grips you tighter. The human pulse behind the probe. At JPL, the Voyager team, now in their 60s and 70s, aren't just technicians. They're stewards of a dream. Suzanne Dodd, the project manager, calls it single string now. No backups left, every system a gamble. When they revived those thrusters in May 2025, cheers echoed through the control room, a mix of relief and reverence for the engineers who built this in slide rule days. Off-record whispers among scientists hint at deeper thrills. If the heliopause's bubbles are highways, could they ferry exotic particles or even hints of alien chemistry? Public outreach amplifies this magic. NASA's live streams of data drops, interactive 3D orbit visualizations on their site, turning raw telemetry into shared epiphany. And globally, the European Space Agency's Rosetta echoes Voyager's waves and comet tails. India's Deep Space Network pings it alongside Chandrayaan. Even the Square Kilometre Array in South Africa tunes in, hunting parallel signals. This isn't solitary exploration. It's a chorus uniting humanity and curiosity. As 2025 draws to a close, Voyager 1 edges toward its next milestone. In November 2026, it'll hit one light day out, 16.1 billion miles, where our commands will take 48 hours round trip, a glacial dialogue with the stars. Power models predict silence by 2027 or 2028, but optimists eye 2030 if we ration wisely. Until then, it soldiers on, 4 instruments humming. Plasma waves, magnetic fields, cosmic rays, low-energy particles. Each bite challenges paradigms. The heliosphere's shape, interstellar weather, the galaxy's hidden architecture. It's a reminder that science isn't about answers. It's about better questions, pushing us to dream bigger. So if this saga has sparked that electric tingle, the one that says, we're not alone in the universe, because we're out there exploring it, don't let it fade. In a world of fleeting scrolls and instant hits, Voyager teaches patience, persistence, the beauty of the long haul. We've reached far enough for the stars to notice our flicker, and in their quiet reply, we glimpse our own potential.